This program features Carnegie Council Senior Fellows Anja Kaspersen and Wendell Wallach, interviewing Missy Cummings. It was recorded on September 30th, 2021.
Today, we are joined by the multi-talented and extraordinary Missy Cummings. It is really hard to describe Missy in a short para, but we'll provide a few highlights. She's currently a professor at Duke University and the director of Duke's Humans and Autonomy Laboratory. Missy is regarded as one of the world's leading researchers in AI and human autonomous system collaboration. However, before her many feats in science and academia, Missy was one of the United States Navy's first female fighter pilots, a role she held for more than a decade. Missy's name is known to most folks who work in the domain of AI and human-centric systems engineering. She has served as an expert to countless high-level governments and industry processes, earning a reputation as someone who always speaks truth to power with deep scientific and social intelligence and her no-nonsense approach to building greater AI fluency. Missy, Wendell, and I have been really looking forward to this conversation with you. And we will get to the big issues around AI and autonomous technologies. But first, I've heard you speak several times of how Top Gun inspired you to seek out a career as a fighter pilot. And in 1994, you became one of the first women in US history to be selected to fly the FA-18 Hornet, which at the time was one of the most technologically advanced fighter jets. I just finished reading your memoirs called Hornet's Nests. And what a journey, Missy. Tell us more.
Well, it's funny looking back. It was a lifetime ago, literally. And, I call it the best of times and the worst of times. I loved being a pilot. I loved flying high performance aircraft. I was really in my element. When people talk about being in the flow, it's amazing when you're in the flow with a high performance aircraft and you're able to manipulate it to do the things that you want it to do. But kind of the flip side of that is the opposite of being in the flow is being in a social melee where people are, they're not happy that you're there. They don't want to talk to you. They don't want to, you're not really part of the camaraderie of what it means to be a fighter pilot. And, it was a slow realization for me that I could be the best pilot that I could be, and I could try my best to serve my country. But if the other fighter pilots did not want me on the team, there was nothing. I could be the best pilot I wanted to be, but nobody's a good pilot, a good fighter pilot by themselves. You need a team of people. And it was that realization, and it was a bitter pill to swallow that I finally realized that, it just wasn't going to happen. I wasn't going to be part of that team. And, there were a lot of reasons for that. And that's what prompted me to start looking around and looking at other options in my life. And at the same time, there were so many people dying that I knew, all because of bad human machine interaction, that it was a real inspiration for me to start looking at ways that I could formally study this and try to change what was obviously a problem.
I remember this line from Top Gun, which I think was by Maverick, the Tom Cruise character. And he says, "You don't have time to think up there. If you think, you're dead." And dramatic as that may sound, I know this is what partially prompted you to transition from your career in the military to thinking more deeply about participatory design and human systems engineering and robotics to make sure that humans are not just a design afterthought.
Yes, what's funny is that I was really motivated to move the Department of Defense away from designing for the human or engineering any part of the system for the human well after a system to be deployed. It turns out that as autonomy and automation have grown in other parts of society, it turns out that motivation is also really important in many other aspects of life, not just military aviation, but particularly commercial aviation. And then as we've started to see autonomy increase in vehicles, passenger vehicles, trucks, even rail, there's still so much to be done in the transportation industry, but also outside of transportation. I think medical systems and the autonomy that may or may not be appearing in medical systems in the future is also going to be a significant extension of this work.
And before we continue, Missy, I'll ask you, just for the benefit of our listeners, to quickly differentiate between autonomy and automation, both of which you have alluded to already, which often gets confused. Could you explain the difference?
Yeah, there is a lot of confusion, and there's no crisp boundary. So whether or not you're an automated system or an autonomous system is really more of degrees of freedom. So an automated system is one that works by clearly defined rules. You can think of a computer program algorithm that's kind of an if then else. If your thermostat sees a temperature lower than what you set, it's going to kick on the heat until the heat rises to that point, and then the thermostat's going to kick off and your system is automatically changing your house temperature for you. Autonomy is the extension of that, where you're thinking more probabilistically. So, is the temperature lower? What time of day is it? Is the owner of the house on the regular schedule? Does the owner of the house have a sweater on? So maybe if the owner of the house has a sweater on, maybe the owner doesn't want the thermostat. So there's a lot more reasoning and guessing behind what the autonomous thermostat, for example, would be than opposed to the automated thermostat. So there are fewer variables for automation. They're much more clearly defined. In autonomous systems, there has to be probabilistic guessing and estimations based on a set of input variables, and maybe not always a clearly defined output set of variables. And so I think that where I tell people to draw the line is really anywhere inside a particular system where the uncertainty is growing to a point where it can be costly. So if your thermostat isn't set correctly, and let's say it's an autonomous thermostat and it guesses wrong, then maybe you just turn it up or turn it down, and that's the biggest consequence of what happens. But if you're in a fighter jet that has autonomy in it and it guesses wrong about what the target is, or you're in a car and it guesses wrong that the obstacle that it's seeing in front of it is not a pedestrian, then these guesses could be fatal.
Missy, you're clearly a leader in illuminating challenges arising in transportation, particularly with the advent of increasingly autonomous vehicles. But you've also publicly warned against allowing any type of remotely controlled vehicles driving on public roads. What are your concerns?
So the remote control of a surface vehicle, a road vehicle, whether or not we're talking about a passenger car or a truck, it falls into this world of automation and not autonomy. So there's really no fancy probabilistic reasoning. It's really, you can think of remote control of a car like just an extension cord. There are a lot of problems when you introduce that extension cord, problems that have been underscored in blood in American drone operations. And so one of the things that we found out early on is the US Air Force, when they started their drone warfare program, pilots were very mad that they were being taken out of the loop for the drone flights. And these are pilots that sit in trailers 4,000 miles away from their target. So they decided to start letting them take off and land the vehicles to make the pilots feel like they were needed. Even though the automation could take off and land much better than humans could, this was still a way to let pilots feel like they were being pilots. And then we found out, really in a very expensive, long set of lessons learned, that when you put a lot of time and distance between that remote control and you get network delays, that is a problem. But you also, on top of that, get what we call human neuromuscular lags. So humans take about a half a second to see a problem and then react to that problem for very simple, like just pressing on the brake. And even a half-second neuromuscular lag, both in aviation, but especially in surface transportation, can be deadly because a lot of really bad things can happen in a half a second on a roadway, particularly a congested roadway. So it turns out that remote control vehicles particularly surface transportation. It's especially acute for cars and somewhat acute for planes, but way worse for cars. You just don't have the time for a remote operator to understand a situation that's developing, respond correctly, particularly with an impoverished information set, meaning seeing the world through two-dimensional displays. And even if they have a whole wall of displays, it's still 2D, and it's still not the same fidelity of information coming into a driver who's physically there.
So there's an additional gap on top of what the driver confronts, on top of what a human driver would confront.
Right. So, I mean, there's delays in the network, delays in the human response, and delays due to a lack of good enough information. So that's all pretty deadly.
I remember you said, Missy, many years ago when we met, that I asked you if you would ride in a self-driving vehicle, to which you responded only when they removed the steering wheel.
Oh, I'm not even sure. Maybe I've updated what I say. I mean, I'm not getting into any self-driving car anytime soon. And I say this all the time because I work in artificial intelligence on a daily basis. I teach students, I grade their papers, I see their projects, and it's not pretty. It's not pretty because they make mistakes that are very typical mistakes, but easy to miss mistakes, and even mistakes that they don't even realize in terms of maybe parameterizing a model. They don't really seem like mistakes. It doesn't seem to be a big deal, but then it has a big deal effect later. So I find that there are so many points of subjectivity in the creation of AI that even designers, even very famous AI statisticians and engineers and computer scientists, they are still making choices about how they design AI that ultimately can have a very deadly impact on how that AI is used. And so I think where we find ourselves in is this really weird world where AI is seen as a mathematically objective tool, but indeed it's an incredibly socially constructed subjective tool. But people aren't willing to admit that because they don't want to admit that they're making choices as opposed to making decisions based on hard data.
So let's talk a little bit about the AI complex that you just described, or the future of AI, the why we should and how we can rethink the maturity of AI in safety critical settings, which is also the name of a recent article of yours about the limitations of deep learning. And you caution in this paper that there's a risk of a new AI winter due to the increasing backlash over AI and privacy, and not least the mindless embedding or fake it till you make it mantra guiding immature AI applications deployed into our day-to-day lives. And you write, in current formulations, AI that leverages machine learning fundamentally lacks the ability to leverage top-down reasoning, which is a critical element in safety critical systems where uncertainty can grow very quickly, requiring adaptation to unknowns. And you argue that this, combined with a lack of understanding of what constitutes maturity in AI embedded systems, has contributed to the potential failure of these systems. And I wonder if you can elaborate for our listeners what you mean by maturity in AI embedded systems, maybe with some examples as well.
So when I think about mature systems with, let's just say, automation at first. So despite the fact that there's been problems with drones, we've also had more than 30 years to iron out the problems. And now drone operations are very mature. We quit letting pilots take off and land. We recognized that that was a problem. We put in the automation. We've got some supervisory humans in who are effectively coaching the system as opposed to trying to directly control the system. And we have understood the problems with the lag and maybe the communications lag and where that can be a problem, and we avoid those areas of operation. So now, 30 years after a technology was introduced, we can say it's fairly mature because we know its failure modes, we know how to prevent the failure modes, and we know how to develop systems that are more effective than others. That's not always to say that we do, we just know how to. And this is why the drone market, I think, is still evolving, because now we're seeing people develop better products, but for the most part, the baseline is generally safe enough. Unfortunately, we're still in the very early days of self-driving cars. And so we do not, what that means is we are still seeing emergent properties, emergent behaviors out of systems that surprise us. And if academics are being surprised by the behavior of machine learning, neural net, deep learning based systems, this is not good, because academics should not be being surprised by a technology that in theory is mature enough for deployment, particularly in these safety critical systems like transportation. And so some of the surprises that we're seeing, a lot of them relate to cybersecurity. So for example, it's actually relatively easy to trick a face recognition system or a computer vision system on a car if you know where to put some tape and how these algorithms, the underlying algorithms, reason. It's not that difficult for somebody with even just a little bit of knowledge to develop a system that can cause for example, their Mobileye has shown some research where they just had to add a little bit of electric tape to a 35-mile-per-hour sign, and it can trick a Tesla's computer vision system to read that sign as 85 miles an hour. So, these are very, very low. The bar is very low for entry to start tricking systems in ways that could cause there to be a threat to public safety. But there are other problems too. Research that we're doing in our lab right now is looking at if you label the underlying data a particular way, can you actually introduce bias in the outcome based on what is potentially a very subjective way of labeling the data? So I think that this idea that data can be curated in a way that dramatically affects the outcome, this is potentially a very big deal. And the fact of the matter is we are now putting computer vision systems out on the road. And then when people see a Tesla car or the Uber car that killed the pedestrian, when they crash and kill people, some people are just shocked, I tell you, that the computer vision system of the cars failed. But we're seeing it, I would take the other side. I'm actually surprised that they don't fail more often, because we know that if the computer algorithms are extremely brittle because of the sensitivity to how the data is labeled, then how much bigger are these problems? Like, where can we draw the line between how do we know how to safely curate a data set so that it's representative of the real world, that there are not a lot of errors in how the data is labeled, that it's crisply labeled enough, whether it's a machine or a human, to get the results that we want. So these are actually some very basic issues that have never been explored that could have a very big impact on safety. So because of that, I would call computer vision, especially in cars, very immature, because there's still a lot of questions that we have not answered. And I think that eventually we'll get there and we'll have some answers and we'll know a lot more, but we're not there yet.
This is a really rich area, Missy, and I'd like to push you a little bit further on it. I mean, you've been talking about mistakes, but you've also seeming to suggest that part of the problem is in the way we're programming the systems. But I wonder whether you're concerned about the unpredictability of AI systems more generally, that it's something endemic, or the unpredictability of complex adaptive systems. Or do you believe that engineers are going to be able to effectively minimize the likelihood of low probability, high impact events?
Well, these are all good questions, Wendell. And I'm going to put this in the framework of, for right now, I'm strictly talking about deep learning systems, any AI system where there's a neural net. Now, there's other kinds of AI, what we call GoFi, good old fashioned AI. We could talk about that later. But in terms of looking at any artificial intelligence that relies at all to any degree on a neural net, so it is my professional opinion that if that system is a safety critical system that you are just simply not going to be, the system will never work in the way that you say it's going to work if it cannot represent reasoning about the world around it in the way what we call top-down reasoning, in the way that humans do, because there's just simply no way to control for all the uncertainty. So the singularity crowd will tell you that if they had all the data of the universe, and we had a massive computer that could process all the data of the universe, that all important relationships, physics, social relationships, everything could be learned in the data. I find this an amazing deep fallacy. So the way that neural nets work, I don't care whether they're a 1-layer neural net or they've got 2,000 layers in deep learning. They all just take data that represents the world around them to learn an association of mathematical weights to represent the world around them. That's it. That's how they all work. And if that system does not see a representation that matches those weights, then the system will never be able to recognize that. And there is no inductive reasoning like humans have. There's no ability to see close approximations and see an almost as if association. And so if we've got a fundamentally flawed technique, like I believe that neural net techniques are, but I just don't think we can ever get there. And by get there, I mean, we can never have systems, AI systems that can learn, that can appreciate that it's seeing something new if it always has to match against something that it's already seen. And so you can't model the universe in this way, because the most wonderful thing about the universe is that it's always surprising us. There is something new. I mean, people say, Shakespeare wrote everything that was always, has ever been read. I don't agree with that. I think humans are very creative, and humans come up with new representations and new relationships, and science is discovering new elements and relationships, not just in our species, but in other species. So I think that this idea that you can take approximations of the world around us and represent everything in that way has just zero insight into what the real strengths of humans are.
I'm thrilled that you brought in the ideas of the singularitarians. As you know so well, there's often a tension between those of us who focus on these near-term challenges and those in the AI community that want more attention directed to the existential risks posed by this future possibility of smarter than human systems. And I've deeply appreciated and witnessed often how you've been at the forefront of much of this discussion. Are there other things beyond the difficulty of representing the world fully for a system, its ability to engage in top-down reason, that you want to share with us? Your thoughts about what you feel are concerns that those who are focused on the longer-term challenges overlook or don't understand?
Well, I am the first person to tell you that I think we need to be very, very careful how, when, and where we're installing artificial intelligence, whether or not we're talking about military systems or medical systems or transportation systems, because I see it as a deeply flawed technology, and the people designing these systems don't appreciate where these deep flaws exist and really how deep they go. That being said, because we've got so many people, so many famous people who fundamentally refuse to accept the limitations of these systems, I think that we see a lot of people, almost like Chicken Little. The sky is falling because AI is about to take us all over, and we're going to go into the matrix and the machines are going to rule. I'm not worried about that at all. I have 0% of my brain that's dedicated to worrying about runaway artificial intelligence that's going to outsmart us and destroy the climate and enslave humanity. What I'm really worried about is all the incompetent AI that is out there, where people are designing these systems. And, we've got very famous people who just simply refuse to acknowledge what I've just said, which is, I don't care how deep your deep learning algorithm goes. It cannot reason out and under uncertainty, ever. And if you're only ever relying it to recognize what it's seen before, especially in safety critical systems, and especially in warfare, you're never going to be able to really generalize that to adaptive situations. Now, that's not to say that there are some places, and I've been very vocal, that in the military, I believe that some artificial intelligence that can do some pattern recognition about buildings that exist and buildings that you have a lot of images of, that you can actually drive the uncertainty down very low, that I believe it's actually more ethical to let AI prosecute targets, static targets, that because the likelihood that the AI will make a mistake is going to be lower than when a human makes a mistake, particularly a fighter pilot who's physically in a plane, being shot at, under pressure. There are some areas where I think artificial intelligence could actually be a real game changer into more humane forms of warfare. I even realize that that's kind of an oxymoron right there. But, I think about what just happened in Afghanistan, where this car was taken out with children in it. Is it possible that AI could have been developed to recognize children? That's not that hard to do, I think. And why couldn't we layer AI, put like a self-check system that if children are detected on any target where there's an incoming weapon, it's actually not that hard to misdirect that weapon to fire into a known safer area where that's not populated. So I think that we should not be throwing out the baby with the bathwater. We need to just be clear about where AI can and can't do the job that we can think that we think that it should be doing. And then instead of focusing on human replacement, we need to focus on collaboration with humans. How can we design joint tasks so humans and AI can work together as a team, as opposed to trying to replace humans?
So you seem to think that autonomous systems should be acceptable for static targets, but it's not clear to me exactly where you stand on more dynamic targets. And obviously the children in the car is an example of that. Do you think we
right. So I think on the dynamic target, I don't think that we should ever let AI, and I think it's going to be true for my lifetime, we should never let AI make a choice to fire a weapon because there's still so much uncertainty. But could we use AI defensively to cause a weapon not to fire? Sure, because indeed not firing is a safe state as opposed to firing. So yeah, I think that for defensive purposes, can we use AI in Iron Dome? Sure, defensively, but offensively, I still think we're just not there. And we won't be in my lifetime.
So, so are you concerned with this thing that we're pretending autonomous systems can be patched once deployed? Do you feel that this is naive, costly, dangerous, and possibly not feasible, as I do? Or is that really not your view? Are you really saying, well, we can do a great deal of experimentation by putting systems out in the field?
Well, my feelings are kind of a little bit of all of the above. Like, look, seriously, patch, no way. Patching is like, there's nothing, if you've got fundamentally flawed AI, there is not enough patches there's no patch. You just can't ever patch a fundamentally flawed system. If that's the problem. Now, I also am a big fan of the idea of doing over-the-air updates for cars, as long as you're not doing over-the-air updates of safety critical elements of cars, right? So for example, if Ford develops a new fuel emissions algorithm that can make your car even more fuel efficient, and we can just upload an algorithm and it just slightly changes the air to fuel ratio, I'm all for that. Now, where I stand against that is if you want to update the computer vision system and you think that you've got a new pedestrian detection algorithm and it's never been tested, I think it should totally not be allowed for you to upload your new pedestrian detection algorithm that's never been tested and use the American public or the German public or whatever public that it's in to do your testing for you. So, that's what I'm saying. When we say patch, I think, I really think of it more as a software update, but we need to be clear that all software updates are not the same. And I think more importantly, what I worry about is regulatory agencies, and this is true worldwide, just cannot keep up with what even that means. Like, how do we even start to address what it means to do a software update in any safety critical system? How should regulation, how does it need to change and adapt where software changes are the big changes instead of hardware changes like we've seen in the past?
Before I turn this over to Anja to introduce some other subjects, I'd like to just go back to this tension with those focused on longer term existential risks. And I'm wondering whether you feel that they're inappropriately dismissing the nearer term concerns that you and others are raising.
Yes, I'm very concerned about the Future of Life Institute, for example, leaping over the near-term problems with how we're starting to roll out AI, because these are real-world problems that touch people's lives. And while, I love H.G. Wells and all the futurist thinking, and I'm all for thought exercises, but when the Future of Life Institute takes the position that AI is mature enough that it's just around the corner that it's going to start selecting people and wiping people out based on its own internal autonomy, what that does is it makes people, potentially governments and funding agencies, research funding agencies, not realize that there are some more critical pressing areas that need focus. So maybe now I think we have a glut of people worried about the existential ramifications of AI, which, I'm not saying you shouldn't think about it, have fun thinking about it. But in the meantime, all of you people who are thinking about existential threats of AI need to start arguing about this over-the-air software update. Like, when is it ethical to do it? How do we draw the line? Where do we draw the line? What about equity? Is it all right for Silicon Valley to develop autonomy that's based on pedestrian crossing behavior in America, and then we export that to other countries where, like China and France and Japan, these cultures have very different road crossing behaviors. And so there are cultural and ethical, equity issues about how we need to develop software to be adaptable to other places and cultures. So again, fine if you want to have the long-term, I would love to sit at a bar and debate with people about whether or not robots are going to kill us all. But on my day-to-day aspect, I need a lot more help looking at the near-term policy ethics of all this incompetent AI running around.
I think those are very important points you raised, Missy. And I've heard you say many times, beyond the sort of existential risks, we have something much more immediate, which is just human boredom and our inability to deal with automated tasks. Can you say something about that?
Yes, well, I got into the boredom research when I was doing a lot of work for the military and their drone programs. And we just saw, how operators would just be sitting for hours bored out of their minds and looking for anything to do to stave off the boredom. People can be in, literal physical and mental pain over when they're exposed to long boredom, vigilance, monotonous tasking. And so I think that's what motivated me to get in there. but then what I recognized is that the lessons learned in the driving world, we're starting to see, and this has been true historically, that aviation is the first to introduce automation, and we see all these problems, and then they eventually, a few years later, show up in the automotive world. So, and you can see this in spade in all the Tesla crashes. And so I'm a big fan of Tesla. I like Teslas, except I'm not a big fan of full self-driving or autopilot, because the systems give you the impression that they're more capable than they are. And what we know from years and years of aviation automation research is automation just has to be good enough. It doesn't have to be great. It doesn't even have to be near perfect. But as soon as automation looks like, or autonomy has some competence and can do a job a little bit, humans have a tendency to get bored very quickly and then give up the legitimate authority to that automated systems. And so we're seeing people crash. I mean, it's almost like a day doesn't go by where I don't get somebody tagging me on Twitter that there's been some new Tesla crash where a person was on autopilot and crashed into the rear end of a fire truck or a police car or the broadside another truck, and some have been lethal and some people have lived through. And so we have to recognize that this babysitting of automation, it's a problem in the aviation world. And I do know firsthand that because the environments are so boring, that many of my peers that I flew with in the military, I think every man and woman to a T has told me that they wish that they had done what I had done, which is move into academia, because they find that the flying of aircraft it can be so boring and tedious. And, we've got highly trained people who at least have somebody else in the cockpit to keep them entertained. In cars, we don't have that. And people have their cell phones next to them, and they have the neuromuscular lag problem that we talked about before. So now it's like the perfect storm. People have pretty good automation, but not perfect. They're bored, their cell phones are there, and I just need to look at my phone for a little bit. And then something bad happens and I just cannot respond in time. And so boredom is important in autonomous systems, because we have to recognize if we don't do something about the way we're designing the job and giving people meaningful work and meaningful activities in that job, that boredom is going to result, and then bad things can happen once people are bored.
So what you're saying is that boredom in some ways makes us relinquish that control. It's not the trust in the machinery or in the software. It is the tediousness that prompts us to relinquish that control in some ways.
Yeah, I think it's kind of a joint. I think because we see the automation perform good enough, it doesn't have to be great, just good enough, that we develop inappropriate trust, and that's exacerbated by the boredom. So the boredom, we want to believe, and you can watch many YouTube videos where people want to believe that the cars are far more capable than they are, because they want to believe that they can provide themselves with meaningful work. And I think that's kind of the funny thing, is like, we need to recognize that people, both in cars and in process control plants and in cockpits, people get distracted because they're trying to stimulate their brain. They want something meaningful to do. Now, we may not always agree with what their definition of meaningful is, but their brain is craving activity. And so if we know that, and we know that that's the end state to pretty good but not perfect autonomy, then we need to do more to make sure we can at least try to give people meaningful tasks. Or if we can't do that, and it's difficult in driving, right, that we can at least design the system to mitigate the consequences of their boredom.
Have you experienced pushback for some of your work and trying to sort of speak truth to power, Missy? Been trolled, cyber stalked?
Yeah, it's funny, through my career, I spent my first 10 years of my academic career at MIT, and I was doing so much drone work. I got a lot of pushback because people at the time saw this as a horrible military weapon, and how dare I do research to help the military war machine. So that landed me in some hot water at the very beginning of my career. But then, and in fact, if you actually go, I was on the Daily Show with Jon Stewart, and I'm trying to talk with him about how drones are not going to be, they're not just a military technology, that their real value is in commercial technology. And he's very funny. He makes fun of me, and we have a good time over that. And I, at that time, social media, Twitter, was just emerging. So there wasn't a lot of ways for me to get directly attacked. Although I have to tell you, I got so many bad, very mean reviews of articles that I would write. I would get reviews like, what are you doing this work in drones? It's a niche technology. Nobody cares about it. It's just a military technology. You're barking up the wrong tree. So, I know what pushback is from the very beginning of my career. And indeed, because drones then commercialized fairly quickly, and in fact, right after my Jon Stewart appearance, then I slid over into the autonomous cars because I knew that this was going to be the next big area, certainly for the research that I do. And, I've been in that space for about 10 years now, and I've been very vocal about the limitations of technology and how it applies to many, many different transportation systems. But obviously with cars, we're starting to see a significant uptick in the consequences to people's behavior. And it would be one thing, I guess, if drivers just killed themselves, but now we're starting to see other people killed, either in passengers in the car where people make mistakes, or in the case of the people whose cars are being hit, like first responders, police. So I feel like, and I'm one of the few academics that I'm old enough, I call myself a curmudgeon. I'm old enough and I'm far along in my career. I'm totally protected, right? I've got tenure. I can say whatever I want. And because I'm in this protected place, I'm going to speak truth to power. I'm going to tell people, look, I want this technology, but I also recognize that the technology is not there yet. And it's probably safer for the public that my 14-year-old eventually learned how to drive, as opposed to turning it over to self-driving cars that can't even closely approximate, what will eventually be a 16-year-old. So a lot of people push back because they don't want me to basically reveal what, by the way, and this is what's so crazy, like everybody in machine learning, everybody in computer science, everybody who really understands this technology knows I'm right. They know I'm right. They know that this technology is not going to generalize, but there's also so much money that universities get to tell companies and government agencies what they want to hear. Nobody wants to fund anti-innovation. People only want to fund the next new cutting edge whiz-bang technology. I personally think we should be funding a lot more process-oriented research, like how do we know when AI is trustworthy? People don't want to fund that. People want to fund very cool AI that's going to revolutionize the way we get to work. Okay, well, these two things go hand in hand. You really do need to be doing the process at the same time as the tech development, but nobody listens to me. And not only that, when I start pointing out areas where things have gone really wrong, like, unfortunately, Tesla's the one that's out there the most because they have the most advanced cars, but they also have the most egregious examples of bad autonomy in the public's hands. And so I use those examples because they exist. Again, I don't even have to, I just have to open up my daily email or Twitter feed to find the latest example of how autonomy is going wrong. And what we see is the Tesla, I would call it the Tesla Illuminati approximations, the Tesla fans who are really pushing the stock price. And that's my theory, is that people who own Tesla stock are really trying to push it up. We've got fanaticism that, I used to say it borders on religious fanaticism. I think it's squarely in the religious zealot space. People, when I start to say, look, autonomy designed incorrectly is bad. And by the way, here's some examples, one of which includes Tesla. then what I do is, I've had to shut my Twitter account down to temporarily because of bad boy behavior. I'm constantly besieged at work with complaints, anonymous complaints, mind you, to the point where, I am considering what are my personal security options and how might I have to change my life, because people are so mad that I'm speaking the truth. And I think that this points to, where we are in our society in the year 2021 is, we are having trouble. We just as a society, splitting fact from fiction. But even when a researcher speaks truth that everyone who's in the field knows is truth, that the public or elements of the public can start pushing back so much that they start to, people are trying to silence me. And I do wonder, how far is this going to go? How far are people willing to go to silence science that disagrees with their stock price?
I'm sure that our listeners would also agree on the unacceptability of this type of behavior and attempts to silence, like you said, diverse views in this field. I would like us to dive just deeper into the unique intersection between science, the future of mobility, international security, and next generation military affairs and warfare, which you had already alluded to, in which you operate, Missy. And a core concept in military affairs and culture is that of command and control. You have written extensively about the potential and real yet often unanticipated impact of AI systems on decision-making support systems for revolutionary command and control domains. Can you share with us just briefly your thoughts on this and how this will change the character of warfare and maybe even the nature of warfare looking ahead?
When I look into my crystal ball and I think, how is artificial intelligence going to change warfare? I think for the most part, it just extends ideas that we've already had in warfare. And by that, I mean, we have been trying to back up the distance that we kill other people in warfare since the dawn of the bow and arrow, right? As cavemen, we had clubs and we decided that was distasteful. And then we moved back to bows and arrows, and then we moved back to guns and missiles. And now we're trying to get, we have long range bombers, and now we have artificial intelligence where in theory, we can launch whatever weapon we want from whatever distance we want, and the vehicles can potentially sort it out themselves for how to execute our plan. And so I don't think AI has actually fundamentally changed what people try to accomplish in warfare, but I think it changes how they potentially go about it. And I do worry that the step change that we're seeing is not a step change in goals and intentions. It's a step change in competence of people building these technologies. And I mean that to say, software development is hard. It's very hard. But companies and even academia treats software development as a necessary add-on feature and not its own entity. And because of that, we do not have enough people in leadership positions, in development positions. We don't have people who really appreciate, and this is true in the government and all governments, by the way, all nation states and all nations' industries. We just don't have enough people who understand the nuances of what it means to start developing primarily digital systems that occasionally rely on hardware. Most people think it's the other way around, that we have some hardware and maybe it has a little bit of software in it. But we are at a step change where the real capabilities are now going to be virtual, and hardware engineers, for example, mechanical engineers, I'm sorry, mechanical engineering, you're going to be important in the future, but you're not going to be important if you don't understand how software comes into your system. And so I actually think engineering needs to fundamentally change. All of engineering, all engineers should learn how to code. And that is not a popular viewpoint. And I'm not saying everybody needs to be a hacker, but everybody needs to understand what it means to code, how code works, how we develop these systems, where the error states are, because they affect every other system. And so the step change that I see going forward is then the military nation states that are going to rise up are going to be those that can command the software, who know what they're doing with software, instead of the countries who still predominantly rely on a hardware-oriented mentality.
So command and control the software.
That is correct.
There's been this massive upsurge in AI ethics with principles and standards and guidelines. And I'm wondering whether you perceive that there's ethics washing going on, or in your experience, have most parties been sincere in their attempt to ensure that their applications are not only safe, but function appropriately?
My feeling is that when I think about military applications, I think that, I can speak to the US specifically, and I have also a lot of European peers. So I do think that Europe and the US are trying hard to think through some of the ethical implications of AI and weapons. And that's actually not that surprising because, for example, all the military agencies have been formally teaching ethics always, right? So it's not that they didn't, this is not new thinking to them. So we could argue maybe about whether or not their thinking is correct or whether or not you agree with their thinking, but they at least have explicit formal programs in the ethics of AI. I think the bigger problem are corporate companies who, whether it is either intentional sticking their head in the sand or just not even realizing that there are ethics surrounding these issues.
Ending where we started with your courage, Missy, in your memoir, you speak about the difficulties of being at the vanguard of cultural change. And building on your experience from being at the vanguard of changes in the military, you're working in human factors system engineering, and as an experimentalist, what are the 1 or 2 insights you can share with those listeners who will find themselves being at the vanguards of change?
Well, it takes courage to step up and speak the truth, but we're never actually going to get systems with AI in them to work if people keep ignoring the elephant in the room. So you got to stick with it, and you have to be at the right place in your career. It's a luxury for me to be able to speak truth to power because I'm in a position where people can't fire me for speaking truth to power. Not everybody has that luxury, but I think at least recognizing what the truth is and trying to design systems that don't fail in these obvious ways, I think that's the real challenge for so many people out there who are in the trenches.
Thank you so much, Missy, for taking the time to share your knowledge and insights with us. And thank you to all of our listeners. We hope we deserved your attention and time. And huge thanks to the team at the Carnegie Council for Ethics and International Affairs for organizing and recording this podcast.